Hello, my name is Brianna Kessler, and this is my presentation on the fertigation for tomato production in Florida. I was advised by Dr. Guodong David Leo, and here are the EDIS article IDs that I used to compile this presentation. I hope you enjoy. I will start this presentation by discussing the importance of tomatoes. Tomato, also known as Solanum lycopersicum, is a nutrient-dense vegetable crop and is a multi-seeded berry. Tomatoes contain antioxidants such as lycopene and lutein. Due to its health benefits and flavorful taste, tomatoes are in high demand. All tomato plants are vines, but indeterminate tomatoes grow much longer than determinate varieties. Due to tomatoes' wide acreage, it is important for tomato production to be efficient in its water and nutrient use, which can be improved through fertigation practices. There are many things to consider when considering tomato production in Florida. Tomato production in Florida. Florida fields and greenhouses have been cultivating a variety of tomatoes including cluster, beefsteak, grape, heirloom, and small cocktail. Tomato vines are grown in greenhouses or open fields and for fresh or processing markets. Compared to field production, greenhouse tomato production typically has greater production cost and carbon cost. The conventional fertilizer used for tomato production is mostly water-soluble, such as ammonium sulfate and triple superphosphate. Consequently, the use efficiency cannot synchronize the nutrients with the plant's requirements. Water-soluble fertilizers cause problems such as runoff, emissions, and leaching. Comparatively, fertigating tomatoes and providing 3 to 4 applications each day will have a higher use efficiency. There are different types of fertilizers to use for tomato production based on physical state, that means solid, liquid, and gas, and solubility. Solid fertilizer, you can use dry granular, controlled release fertilizer, or slow release fertilizer. Liquid fertilizers include water-soluble fertilizer and fertigation, which is a mix of water-soluble fertilizer and water. Then there's gas fertilizer, and that is CO2. Now I will talk about dry granular fertilizer. Dry granular fertilizer is a main method of fertilizer application. It can be applied using a variety of equipment and can be used on a wide range of crops. Dry granular fertilizer is usually less expensive than liquid fertilizers. It can be stored for longer periods of time without losing their effectiveness and are easy to transport. It also supplies the soil with a larger quantity of nutrients at one time, thereby enhancing the likelihood of leaching occurring. Now I will go on to talk about controlled release source fertilizers. Controlled release fertilizers, as shown in Figure 1, have an advantage over conventional dry fertilizers because they can be applied at a relatively higher rate during the basal application and reduce the application frequency. Find control release fertilizers that are specifically for tomato vines, in which nutrient release rates and timing synchronize with nutrient requirements during different stages of growth and development of tomato plants. The current cost for CRFs is about 2 to 3 times higher than conventional fertilizers. Tomato growers prefer to mix CRF with conventional fertilizers in basal dressing for tomato crops to reduce the cost and meet plants' immediate needs. Dry granular fertilizer and control release fertilizers both have their perks. However, fertigation may be ideal for tomato production in Florida. Fertigation for tomato production. Conventionally, growers use dry granular fertilizers for tomato production. However, fertigation is a method of nutrient application that involves injecting water-soluble fertilizer into irrigation. Fertigation is the better tool for the 5 R's because the micro applications are extremely beneficial and can maximize nutrient use efficiency and water use efficiency. It can improve the yield and minimize the environmental risks brought upon by crop production. Fertigation also allows for precise fertilizer management and reduction of nutrient application rates and costs. Fertigation also reduces leaching, ammonia volatilization, nitrification, and denitrification. Mahajan and Singh in 2006 found that nitrogen fertigation increased yield by 59.5% in the greenhouse and 116.2% in the field compared to conventionally applied fertilizer at recommended rates. Hebar in 2003 found that water-soluble monoammonium phosphate 12-52-0, potassium nitrate 13-0-46, and urea 46-0-0 fertilizer application at the rates recommended through subsurface drip irrigation increased tomato growth and yield compared to soil-applied fertilizers with furrow irrigation. There are numerous advantages when choosing to fertigate for tomato production. Now I will go into the advantages of fertigation for tomato production. The advantages include synchronizing nutrient supply and crop requirement. This means that nutrients are supplied uniformly to the root zone as they are required by the crop. Fertigation allows for greater crop yield. By applying nutrients with water, it has been shown to result in greater crop growth and yield in both fruit and vegetable crops when compared to traditional soil application methods of fertilizer. Another advantage of fertigation is that there is greater nitrogen use and water use efficiency, where nutrients in soluble forms are already available for plant uptake. Fertigation allows for reduced labor time. Fertigation systems are often comprised of automated controls. Fertigation also reduces groundwater contamination because fertigation reduces fertilizer inputs and nutrient leaching. Another advantage is suppressed weed pressure. Drip irrigation and fertigation provided reduced water and nutrient sources for weeds. Now I will go into fertigation system establishment. While fertigation may be implemented in sprinkler irrigation systems such as center pivot, it's more common to use micro irrigation. Here it is shown in figure 2. For fertigation, because of the application frequency, the operator-controlled inputs, and better control of leaching and nutrient accumulation. When establishing a fertigation system, it is important to consider the crop species and growth stage, soil characteristics, the water quality, and the fertilizer composition. Here are some recommendations for setting up a fertigation system. So one recommendation is a 15-minute flushing after each use. This is recommended to prevent common problems such as precipitation, emitter clogging, or corrosion. Recommendation number 2. It is required by Florida law to prevent backflow by installing a vacuum breaker, a low-pressure drain, and check valves. Recommendation number 3. Subsurface drip irrigation systems may last 12 to 15 years with proper upkeep and good water quality, but thin-walled drip lines must be replaced each crop cycle. So keep these in mind when setting up a fertigation system. Fertilizer preparation for tomato production. Use fertilizers with high purity, high solubility, low salt index, and near neutral pH regulated to mitigate precipitation reactions. Tomatoes grow well at slightly acidic to near neutral pH, with optimal pH values ranging from 5.5 to 6.8 and a target pH of 6.5. Stable irrigation water pH for tomato vines has been shown to be maintained between 1 to 4 and 1 to 3 NH4 to NO3 molar ratio. Bacterial growth may be prevented by injecting chlorine as sodium hypochlorite at concentrations of 5 ppm. To prepare fertilizer for fertigation, we must go over our fertilizer options to supply nitrogen, phosphorus, and potassium to our tomato production. Nitrogen application. The most desirable forms of nitrogen fertigation sources because of the low plugging risks are urea ammonium nitrate, potassium nitrate, and ammonium sulfate. Calcium nitrate 15.5-0-0 and calcium ammonium nitrate 17-0-0 are also soluble but are less frequently used because of the potential precipitation of phosphate ions with the calcium ions. Now I'll go over phosphorus application. Garijo and Hotchmott found that fertigation at rates of 22.3 pounds per acre of phosphorus, which equivalates to 25 kilograms per hectare, with 64.2 pounds per acre, pre-plant improved Florida tomato marketable yield. Phosphorus fertilizers that may be used in fertigation systems include monoammonium phosphate, diammonium phosphate, phosphoric acid, urea phosphate, and liquid ammonium polyphosphate. Phosphorus may interact with irrigation water, especially if calcium is present, so care is needed to ensure the proper application of phosphorus sources. Phosphoric acid, green 0-52-0 and white 0-54-0 may have acidification effects that may reduce precipitation potential. And because of the potential for phosphorus fertilizers to precipitate, it may be advantageous to separate the application of phosphorus by using different lines or temporal breaks with flushing during the interim. Now I will discuss potassium application. Potassium injection has been largely successful because of the high overall solubility of potassium fertilizers. Here are the most used potassium fertilizers. Potassium chloride is the least expensive and most popular K sources for fertigation. Potassium nitrate is also an appropriate choice, particularly for saline irrigation water sources. Potassium should be minimally used or avoided in fertigation systems with these in mind. Potassium sulfate should be minimally used or avoided due to the low solubility. It may be used in irrigation water sources with possible saline issues, but this fertilizer is less soluble than potassium chloride. Another one that should be minimally used or avoided is monopotassium phosphate. It should be avoided due to the high precipitation risks. Before applying fertilizer through fertigation, we must look at planting dates for the area in Florida where your tomato production will take place. Here are the tomato planting dates in Florida. For open field Florida tomato vines, the planting dates are from July to August and February to August in North Florida, from August to September and January to February in Central Florida, and from August to February in South Florida. We must consider plant spacing for open field tomato production. So, as for tomato plant spacing, for open field tomato production, tomato beds are 36 to 40 inches wide and 6 to 8 inches high with 6 feet between the centers of adjacent beds. Tomato transplants should be spaced 18 to 24 inches apart and set 2 to 3 inches deep, either in a single row or in 2 rows with 10 to 15 inches between these rows. Tomato plants are spaced 48 inches to 72 inches between rows and 18 to 32 inches between plants. Now we will look at pre-planting and mid-planting tomato operational procedures and recommendations. Pre-planting tomatoes for fertigation. Prior to setting the layout of plastic mulch and drip lines, here are some things to consider. Take a soil sample and submit it for testing to see what elements are in your soil already. Combine fertilizers containing nitrogen, phosphorus, potassium, and some micronutrients including iron, zinc, and copper are usually applied as a basal dressing, shown in Figure 4. The common formulas of combined or mixed fertilizer can be 8-16-16, it could be 10-10-10, it could be 6-6-12, or 12-12-12. of N, nitrogen, phosphate, and potash, and percentage same as following. For pre-plant application in Figure 5, pre-plant fertilizer should be applied in 2 parallel bands, each about 9 inches from the center of the bed. Next, the bed should be rototilled to a depth of 4 to 6 inches, and then the bed must be reformed. The bed should be irrigated and kept moist for at least 1 week to promote the germination of weed seeds. If the bed has become dry, irrigate 1 day before the application of a fumigant. Soil fumigation with T-Lone, except for Miami-Dade County, KPAM or VPAM or Dominus, is also applied for pest control. As for Miami-Dade County, during the fumigation operation, 1 or 2 drip irrigation tubings, 12 to 14 inches apart, are installed in the surface layer, and the bed is immediately covered with plastic mulch. Immediately after fumigation and mulching, an herbicide should be applied to furrows. Then you should wait at least 3 weeks after fumigation before transplanting tomato seedlings to make sure it's safe for the tomatoes to start growing. Mid-planting tomatoes for fertigation. To provide a successive amount of nutrients to tomato crops, a liquid source with nitrogen and potash at 4-0-8 or 3-0-10 shown in Figure 6 is applied with the irrigation drip lines. The liquid source is essential for meeting the tomato requirement for nitrogen and potassium during the fruiting stage. The determination of liquid type, application rate, and starting time for the liquid fertilizer depends on the fertilizer sources applied at the pre-plant stage. And liquid fertilizer can provide plant nutrient needs more quickly and efficiently than conventional dry fertilizers or controlled release fertilizers. Now, let's look at the UF IFAS fertigation recommendation for open field tomato production. Now I will discuss the nutrition for tomato production. The UF IFAS fertigation recommendations for Florida field tomato production are: for low melic 3 results, 200 pounds per acre of nitrogen, 120 to 150 pounds per acre of phosphate, 125 to 150 pounds per acre of potash. And for medium melic 3 results, it is 100 pounds per acre of phosphate and 100 pounds per acre of potash. The application of nutrients is divided over a period of many weeks. Micronutrients are applied less frequently through fertigation methods because of the low demand by plants and possible low solubility in water. Micronutrients may be supplied in fertigation if they are in acidified, hydrated forms or chelated forms. Time to dive into a real-world example. So let's practice. Tomato plants on 6-foot bed centers. The nitrogen fertilizer recommendation is 200 pounds per acre. Using 6-foot typical bed spacing, the recommended fertilizer rate is 100 pounds per acre. In Figure 8, it does not have an amount for 200 pounds per acre. We will be using 100 pounds per acre and later multiplying it by 2 to achieve the recommendation for 200 pounds per acre. So using Figure 8, you will use 1.38 pounds of nitrogen per 100 linear bed feet, or LBF. You will want to double this amount because we used the 100 pounds and the recommended rate was 200 pounds per acre. So you will need to apply 2.76 pounds of nitrogen per 100 linear bed feet. You can check your math by noting that there are 72.6 100 linear bed feet in an acre of beds on 6-foot centers, shown in Figure 7. Note that 72.6 times 2.76 equals 200. If your fertilizer is 25% nitrogen, then you will apply 11.04 pounds of fertilizer per 100 lbf. This calculation is 2.76 divided by 0.25, and that equals 11.04. Please keep in mind that this is the amount for the seasonal crop nutrition requirement, and you might be planning on split applications or applying in weekly amounts through the drip irrigation system. Now take 11.04 pounds of fertilizer and divide it by the number of weeks of your growing season, shown in figure 8. In Central Florida, the growing period is 8 weeks. So we will divide 11.04 pounds by 8 weeks, and you will get 1.38 pounds per week. Then divide 1.38 by 7 days of the week, and you will get 0.197 pounds of fertilizer to be applied every day of the week. And that concludes my presentation. I hope you learned something new. Here are my citations, and thank you for following me through my presentation. Bye.